Alright, well this is to go along with the 1.2, 1.3 video that I made the other day. I didn't realize that there was a whole section that was actually a review section called R.3 that's basically just dealing with fractions. So I thought what I'd do is go through a few examples just to kind of give you an idea how to deal with some of these fraction problems in terms of adding them, simplifying them, writing them as a mixed number and things like that. And then this should accompany, this should be the first 8 or so problems on the homework, and then the rest of the video, that 1.2, 1.3, should help cover the rest of the homework from that assignment. So to start off, the first example is we want to write the mixed number as a fraction. So a mixed number, remember, is a number of the form where you have the big integer and then a fraction to go along with it. And so the goal is we want to turn it into just a single fraction. So the way we do this is we take the 4, the denominator, multiplied by the whole piece, which is the 3, and then add whatever that is to the top part, the 1. So in this case we're going to get 4 times 3 plus 1, and that's going to be our new numerator, our top. So in this case we get 12 plus 1 gives us 13. And then the 4 doesn't change. Our denominator is still the same, even though we're writing this as a regular old fraction. So our final answer would just be 13 over 4. All right. So question 2 is, how do we simplify something of the form 4 over 20? So the idea is, what we want to do is we want to kind of reduce common factors. So what we have to do is think about what things go into 4 and what things go into 20 in common. So for example, 4 I could rewrite as 2 times 2, and 20, for example, I could write as 2 times 10. And since I have a common 2 on the top and the bottom, I can actually cross those guys out and notice, am I done? Well, let's try to keep going. So notice I still have just a 2 on the top, but technically the 10 I could now rewrite as 2 times 5. So again, I've got a common 2 on the top and the bottom, so these guys can cancel out. And so even though it's not written, technically there's a times 1 at the top, because I don't want to have nothing in the denominator. I have to have at least something. So when you eliminate everything, you still have a 1 left over. And I have a 5 on the bottom, so there's nothing else to simplify, so 1 over 5 is as far as I can reduce that guy down to, or simplify it down. Okay, so sorry about that. So let's move on to the next one. So how do we add 2 fractions together? So to add, and so we're going to do this kind of the easy way, where they actually have the same denominator. It's a little trickier if they have different denominators, but for now, all we're going to do is talk about adding and subtracting things with like denominators. So in this case, to add with things that have the exact same denominator, so in this case 7 and 7, all we have to do is just add the tops together like normal, and carry the denominator along for the ride. So in this case we're looking at 2 plus 4 all over 7, which is just 6 over 7. And if that guy would simplify down, you should continue and do like we did in the last problem and try to simplify it down as far as you can go. But in this case there's no common factors between 6 and 7, so that's as good as we can do. We can just stop there. Alright, so same idea for subtracting. We're trying to subtract something of the form 5 over 11 minus 2 over 11. Again, if they don't have the same denominator, this problem is a little bit trickier. But knowing they have the same denominator, again, we can immediately just write this as one fraction. So 5 minus 2 all over 11. And subtract the top. And we leave the denominator alone. Again, we should check to see if there's anything to simplify, but again, in this case, there's nothing to actually simplify. So 3 over 11 is as good as we can get. Alright. Whoops. A couple more. So let's look at, again, this is an add, but in this case we're going to add two mixed numbers together. So in this case, for me, adding this one, I'd probably rewrite it so that the integer parts lined up and the fractional parts lined up. And so the idea is what we're going to do to add these guys together is add the integer parts, so 3 plus 8 is 11, and then add the fractional parts. So again, we're lucky to have a common denominator, so we know our answer is going to be over 10. So all we have to do is add the 7 and the 1 and get 11, 8 over 10. Now the 8 over 10 in this case does simplify, so we probably want to actually do that. So what you may want to do is just kind of take this guy off to the side, simplify it off to the side, and then put your answer back together. So 8 we can think of as 2 times 4. 10 we can think of as 2 times 5. So again, we've got these common factors of 2 that cancel out. And 4 over 5 is as simple as we can get, so we just leave that guy alone. So replacing 8 over 10 by 4 over 5, our final answer would be 11 and 4/5 in that case. Alright. So what if we had one that looked like this? So again, we're trying to add them. Another mixed fraction again. So again, first thing I would do is probably write them up and down. And again, we want to add integer parts together. So 6 plus 5 is 11. 8 plus 2 is 10, all over 9. But now in this case, notice we've got a situation where our numerator is actually bigger than our denominator. Which if you think about from like a pie perspective, if we had 10 slices of pie, but this, pie was actually sliced into 9 pieces, we'd actually want to have one whole pie with 9 slices, and then one extra slice left over. So with what we can do is we can take that 10 over 9 and actually think of it as one whole pie plus 1/9 left over, 1/9 of a piece of pie left over. So what we have to do is take that 1 from here and attach it to that 11, bump that thing up to a 12, and that'll actually give us 12 and 1/9 in that case. So that gives us our final answer for that guy. Alright, finally, one more problem. And hopefully this will give you a good start on being able to do those homework problems. If you do have any questions, of course, email me or let me know. I can write up a quick video on how to do any of these guys again. If you need more detail or anything like that, please let me know. So in this case, we're going to do a subtraction. So 3 and 8/15 minus 1 and 2/15. So again, we're subtracting mixed numbers. So again, doing like we did before, let's actually write these guys up and down. And so the only difference between adding and subtracting is, obviously instead of adding the integers together, we want to subtract the integers together. Instead of adding the fractions, we want to subtract the fractions, and that's the same thing here. So our integers is going to be 3 minus 1, which is just 2. Again, we're lucky we have a common denominator, so we know our final answer is going to be over 15. So all we have to do is subtract the 8 from the 2, which gives us a 6. And so again, does this guy reduce to 6 over 15? It does, so we should do that first. So if we rewrite 6 as 2 times 3, and 15 as 3 times 5, you see that we've got a common factor of 3. That'll actually cancel out between these guys. And so 2 over 5, nothing else simplifies, so 6/15 reduces down to 2 over 5. So we can replace that 6 over 15 by 2 over 5, and that gives us a final answer of 2 and 2/5 from All right, well, I hope this helps. Like I said, hopefully this will help bridge that gap that was missing. I'm totally sorry I forgot about it when I was writing up the 1.2 and the 1.3 video. So hopefully this will help with those first few questions. Again, if you need more information on this, on this, it's in the book. It's section R.3. So if you need to practice some more problems, look in the book. There's a bunch of examples in there and things like that. Otherwise, good luck. Let me know if you have any questions or if you need any more clarification. Otherwise, have a good day.